Good evening everyone, and welcome to the Adelaide Zoo and Zoos SA. My name is Mark Smith, I'm the curator here at the zoo, and it's a real pleasure to have you here this evening during Science Week. Just a couple of quick housekeeping things. If you just arrived, just remember to please check in with the QR code, and if you haven't done that, please do so when you exit. And also, if you need to use the toilets, there actually are toilets. Just go out the doors at the back to your left, and you can follow the signs, and there's a toilet right there. So again, welcome. I'd actually like to call on our ED, our Executive Director, Elaine Benstead, to welcome you all, launch Science Week at the zoo, and welcome the country.
Thanks, Mark. Can you hear us all okay? Mm-hmm. Yeah, good. I presume all the people online can hear us. I'll just trust all my fancy tech people who understand this stuff, because I don't. So thank you so much for coming. I'm Elaine Benstead, the Chief Executive of Zoos South Australia. I'd always like to begin by acknowledging that we are on the traditional lands of the Kaurna people, and we respect their ongoing relationship with this really special country. So Natalie Tampinti, Kaurna Mayana Yata Matanya Mama Tatniaku. That's an acknowledgement of the Kaurna country. But particularly for this evening, it's important to recognise that Zoo South Australia works across many local lands, not just Kaurna country. And you'll hear from Dr. Livy Olds about some of our conservation work, both in South Australia but across Australia. And so our connection with country is broader and deeper than with the Kaurna community. And we always like to acknowledge that and recognise the fact that we've got so much to learn as fairly new people in the Australian country. And we are on a journey and a process of reconciliation that for us at Zoos SA is really important. So you're all our supporters. You know that Zoos SA is a conservation charity. We run Adelaide Zoo and Monarto Safari Park. And while we do receive some government funding, for which we're very pleased, I've got to say the last 17 months, and it keeps growing, I think in a few days it's going to be 18 months, we've been really heavily impacted by the impacts of COVID, as have many organisations, and that's been for us with reduced capacity. We haven't had one day in the last 17 months where we've been able to operate at full capacity. But it's also much broader than that. So there's the business impacts of finance and expenditure, but there's also the impacts on conservation. And they're the things that not many people think about. And you'll hear from Lib. I have had a couple of really interesting texts from Lib over the last 12 months when we're trying to do breed for release programs, conservation programs that don't just sit within the South Australian boundary, and how do we make sure that they don't get impacted. And of course a lot of what we do and the money we make from our visitors gets put back into conservation programs in Australia but also overseas. And so trying to raise the profile of what those impacts are is really important. I'm incredibly lucky to have a passionate team of people who don't let most things get in their way. And Lib is definitely one of those. And so, you know, whether it's pulling an all-nighter, trying to get to a border before it closes, my team do everything that they can to make that happen. And so this evening, as part of National Science Week, and I'm so glad we can actually have a few people here. We are still under COVID restrictions, but last year we couldn't have anyone here. This year we've got a few of our key supporters here, but we're also welcoming people online, and so thank you for those people who've joined online. To hear from Dr. Livy Olds about some of the amazing conservation work in Kangaroo Island, but also some of our other projects. For those of you who are online, I think the idea is you type in questions and my team will make sure that they get asked, because we will have some open discussions. So without further ado, I don't think I need to hand back to you, Mark. I think I'm just going to hand straight over to Dr. Liberty Olds, our amazing conservation manager.
Thanks, Libby. Still not. There we go. It is working. So yeah, thank you all for coming this evening, and for those of you watching online. We really wanted to give everyone a bit of a snapshot into some of the work we've been doing and the science that goes behind doing reintroductions and conservation programs in the wild. Many of you will see snapshots on the news, that snippet of the moment of an animal being released, but there's actually a lot more that goes into these sorts of programs. There's years and years of planning. There's a lot of stakeholders and a lot of people, not just within the zoo itself, but with our external partners. And so we thought I'd take the opportunity to talk about some of that science. And one of the things that we're doing is we're constantly learning and constantly improving. For me, though, we have some pretty important statistics to think about. And I'm not going to talk about the threats to wildlife themselves really this evening, although some of them will come up in the work that we're doing. But we do have a really poor rate of extinction in Australia. So we've seen a number of our mammals, at least 27 of our mammals, for instance, we know have gone extinct. We know that we've lost at least 22 bird species, for instance. But for me, the scarier part is the fact that not only have we lost things already, we're about to start losing things. And so we're looking at a lot of species. More than 1,900 species are listed as threatened in Australia. Plants comprise a large proportion of these, as well as a lot of birds and mammals as well. So we also have a range of ecological communities. So that's a diverse group of a type of habitat and the species that are existing within those habitats. 85 of those ecological communities in Australia are also listed as threatened. So I find these numbers pretty scary, but fortunately, some of the work that we've been doing is really trying to change that and trying to get those species that are threatened back on the ground to prevent these guys from going extinct. So there's a few words that you often hear associated with conservation programs, and I just thought I'd take a moment to explain what some of those words actually mean and what the difference is between them. So we often use the word reintroducing. So reintroducing is a description for a deliberate release of a species into the wild, a species that is no longer there. So it might have lived there previously and you're reintroducing it, you're bringing it back. We talk about protecting species, and that's really about keeping habitats and those species safe, so providing protection for them. Rewilding is another word that's becoming increasingly popular and used a lot more, and it's a lot to do with the science behind doing reintroductions. So rewilding itself is about doing reintroductions of lost species that serve an environmental function. And I'll give an example of that, which is quite a widely used example of Yellowstone National Park in a second. The other word that we use all the time is translocation. And you often hear translocation and reintroduction being used a little bit interchangeably. That's because translocation actually describes the act of moving those animals. So when you're undertaking a reintroduction, you're actually translocating those animals. It's just that they're going into a place where they aren't occurring anymore. Our example of Yellowstone Wildlife National Park is a really great example of a rewilding program where they undertook an early reintroduction about 25 years ago of a wolf. They put the wolves back into Yellowstone, and I don't think anyone was quite prepared for what was going to come next. They put the wolves back. Wolves are an apex predator, so they're right at the top of the food chain. They started taking away some of the poorer conditioned elk and some of the other hooved animals that live in the area. And once we started losing those animals from the system started to improve. We started seeing changes in waterways, changes in the conditions of the soil. And as we started seeing changes in conditions of the soil, it allowed things like beavers to start coming back into the system. And things like beavers then create their own change. Beavers were able to come back and they were able to start creating dams. And so from just a simple reintroduction, I say simple, it's really not very simple at all, but from reintroducing wolves, all of a sudden we have changes in waterways. Now you wouldn't necessarily think that by reintroducing a carnivore like a wolf, you would have this flow on mainstream change. And so rewilding for us is really about that environmental function that those species serve. And a lot of our reintroductions in Australia are starting to shift into putting species back into systems that create those ecological functions. So like I said, it's not really a simple process. And we will go through some of the key things that go into a successful reintroduction this evening. And it's a bit like writing a recipe for me. You have a lot of different ingredients, you put a lot of things on the table, and if you don't get those things right, things aren't necessarily going to go to plan. And of course, every species is different. So you need to think about what those needs are for those particular translocations or reintroductions. It's not going to be a one-size-fits-all solution. One of the key parts is that if you leave some things out, you're going to risk your success. So you need a lot of those stakeholders to be coming together. You need a lot of that scientific data to be underpinning what you're doing so that you can ensure the best success possible. One of the challenges we have, and particularly in Australia, is that we actually lack a lot of knowledge. And so whilst we might have most of the ingredients we think we need, there still might be one or two things missing, and we need to ensure that we build some flexibility within those programs so that we can learn from what's happening, from the results that we're seeing. Just like Yellowstone, where all of a sudden the systems are changing, they have to change their plans to be able to compensate from that. And it's a really important aspect, the science behind reintroductions and that continual learning to improve and improve your outcomes. So really, species being out in the wild is about survival. What are those things that you need for species to survive? There are really critical aspects. What food do they need? What sort of habitat do they need? What do we need to make sure is in those environments for those animals to be able to thrive? And if you think about it, we are animals ourselves. Our needs aren't that dissimilar to animals out in the wild, and our environment really plays a major part in what those needs look like. So our theme this year for Science Week was about homes. We've all been spending a lot more time in our homes than we necessarily would have, whether that's doing studies at home, working from home, waiting for COVID tests from home. It's really been a critical part of our lives, and it's a critical part of what we do when we're working with wildlife. It's the most critical aspect for them. Animals need somewhere to live, and if they don't have somewhere to live, they're not going to be able to survive. We have an environment here, and some of you might have heard the speech, the Science Week talk last night about the homes that we create here and providing that place to live within the zoo environment. The same applies to the wild. Animals need to be able to survive. And when you start to see environments changing, the homes that these animals have change. It could be from land clearing, it could be from climate change. Either way, that doesn't really look like a particularly appealing place to me. And I imagine most animals wouldn't find it particularly exciting either. So we need to make sure that these animals have somewhere safe, somewhere that's going to provide them with what they need. But how do we know what is within those environments? And so we have a whole range of scientific tools that we use to understand habitat, to understand what those environments look like. Our technology has changed a lot over the last few years. We can use tools like aerial mapping, for instance, and that's a picture of South Australia. And a really great example down the bottom is you can actually see Kangaroo Island, and just from that aerial photo you can see that the western end of Kangaroo Island has a lot more dense vegetation. That's because before the recent fires, a lot of it was healthy national park. We go out into these areas and we collect really detailed information, and there's some scientists there taking information out in the field from the habitat. We collect things like the information on this data sheet, which is pretty hard to see on this screen here, but we collect information about what species of plants are out there, what the ground looks like, what sort of topography there is. All this information that we can use to start to build a picture about what that environment looks like. we can then ask those critical questions about that habitat. Is there enough habitat there for the animals that we're interested in to be able to survive? Can we use that habitat? Do we need to be doing anything else in that environment to make that environment safe for them? And when we undertake these habitat assessments, we think about them in a really species-specific way as well. For instance, if you were to be looking at a habitat for a reptile, you might be looking at what's happening on the ground, what the rocks look like on the ground, what sort of grass cover there is. If you were looking at a species like a rock wallaby, you'd be looking at the rock crevices right up on the top of the hill. How deep are those rock crevices? What sort of shelter are those things going to be providing? And so we use these scientific tools to really inform how prepared we are with those habitats to be able to put some of our species back. They're not always in great condition. There's a couple of examples here where you can actually see they've set up an exclosure in the top. And within that fenced area, the little square, some of the herbivores that live in that area, so hoofed animals, haven't been able to get in there and access it. And you can see the grass and the things that have been growing back. Similarly, on the bottom picture, that's an area that has had a fence put up and has excluded horses in Victoria. And so on the left-hand side, you can see that the ground's quite healthy, that there are some ground cover species growing in it. On the right-hand side, you can almost see some of the hoof prints that have been created just by having these animals that have been introduced into that environment and not necessarily naturally occurring there. So if you were to do a reintroduction, let's say, of a skink into that area, I think everyone would choose to be reintroducing it into the left-hand side and not the right-hand side. So we need to think about how we create those environments as well. In different areas, we might do things like revegetation, so planting out areas to bring those important habitat plants back for those species. Some of the other really important aspects that we need to think about is what food is available for species in those habitats as well. And is that food suitable? And you'd imagine something like this where, you know, the food requirements for a tiny emu wren that weighs about 5 grams is very different to a yellow-footed rock wallaby, for instance. And so if you were going out and you were trying to understand what's left within that habitat, for the emu wren, you might be doing insect surveys to try and understand what diversity of insects is left within that area and in what sort of abundance. Are they going to have access to enough food and resources for them to be able to survive? I don't think yellow-footed rock wallabies probably worry that much about what sort of insects are in their environments. They're more interested in the grass and browse species. So you'd be looking at vegetation in a different way. And so for me, that's a really important aspect, and we think about it all the time in the zoo. What are we providing for those animals? What nutrients are they getting from their food? And the same applies to our wild situations. We also have to think about what the conditions are like. We might not want to go out on a rainy night. Other species are very similar to that. What has the weather been doing in the recent history? What is predicted for the upcoming conditions? And these are just some pictures here. This is actually what South Australia looked like in July this year. And you can see the different amounts of rainfall that have occurred across those areas, what the maximum temperatures look like and what the minimum temperatures look like. We also really need to think about what seasons we're doing work in. You wouldn't necessarily want to be putting animals out when it's really, really hot, because they're going to have to work hard to get enough water resources, enough food resources to be able to survive. And we've learnt a lot along the way about how important these things are. A really great example is people used to do reintroductions, particularly in the winter seasons, because when you go out and you look at the vegetation, it's green. It looks really lush. It looks like you're going to be reintroducing these species back into a really great paddock or back into a really healthy environment. But what actually happens in winter is we have quite fast-growing grasses. Those grasses tend to be really high water content and pretty low nutrient content. So you're basically sending animals out on a bit of a supermodel diet where they don't necessarily get the nutrients, but they get a lot of water. And so for an animal that might be stressed from the translocation or reintroduction process, you want to make sure that those nutrients are available. And so what we're seeing on the surface and what we used to think were great conditions, we've learnt from analysing those grass species and learnt from what's in those animals' stomachs, so that we can make the right predictions and change how we do things to give them the best chance of survival in the wild. A huge problem in Australia are with our introduced predators. So two of the biggest species that create our problems are with cats and foxes. Cats, for instance, in the wild are known to kill an estimated 3 million of our animals every day. So we're looking at probably 2 million reptiles, maybe 1 million birds and 3 million mammals. That's a lot of animals to be losing. And it's a bit of a graphic example up there, but that top picture is actually mice that have come out of one cat. So that's the stomach contents from one single cat. Now, they're house mice, which are a pest species in themselves, but you can imagine that if that cat could eat that many house mice, if there were still those native animals in that area, it'd be making a pretty big impact on them. We use some really important tools out in the field as well. So they're pretty elusive kind of species. We don't have the time either to stand out and watch to see if there's going to be a fox walking by. So we use tools like remote sensing cameras. And these are actually pictures that have been taken from a camera set out in the wild. I say remote sensing because they have a motion detector on them. And so when an animal passes that motion detector, and there's an example right here, this is a little remote sensing camera. They walk past that camera and it takes a photo of them. They have a really fast trigger speed, so they're less than, I think they're about 0.17 of a second now. And they take little bursts of photos, or you can even get videos. So you can get a really good picture of what's happening with those animals, even though you're not standing out there. And we can use that information to understand what's going on in the environment. This picture on the left is actually the tip of York Peninsula, and we've been doing a lot of predator monitoring out there more recently. What those dots on that picture are indicating predator occurrence. So we can see with those dots, and they're a bit faded on the picture, but you can see the different sizes of the dots and the different colours of the dots are indicating how many times that cat or a fox has been detected on camera. And you get an idea of what hotspots you might be having in the environment, where you can then go and undertake some targeted work to try and remove those predators before you do any reintroductions. We also use that information to look at things like the relative abundance. And the graph at the top shows the abundance, the relative abundance, so how many foxes or cats you might see compared to a particular time and place. And you can see, it's sort of a bit faded, but there's a little arrow in a box, and that indicates when we've had an aerial baiting event. So that means that we've gone out and we've put some baits out into the environment, and we want to know if those baits have been successful, whether the animals have ingested them. And what we can see from that graph is before that baiting event, we were getting lots of detections. We were seeing quite a few foxes and cats in the environment. After that, the numbers dropped down, and there was a gap where we actually didn't see any. So it's highly likely that a lot of the predators in the environment had picked up those baits and taken those baits. We also learn about baiting programs, and an example from the bottom there is the redder baiting events there, and we can see what's happening across time with the numbers of predators we're seeing in the environment, with the amount of baits that's being laid as well. So we can also look at when those numbers drop significantly, and we talked about climate just a moment ago and seasons. We can understand from that sort of information when are the best times to be going out and doing those baits. If we bait in summer, you know, are the animals hungry? Are they going to go out and take those baits? As opposed to winter, where there might be a few other species around, there might be more mice around, they might preferentially be taking mice as opposed to those baits. So we learn how we can use those tools to be most effective. And this is a really important part of our reintroduction programs, because predators can have a pretty significant impact. And so part of Zoos SA's work is working with our partners that are able to be out on ground, the local landscapes board, the state government, who can deliver a lot of those baiting programs and work with the local landholders, and we partner with them to support them in being able to do that. So one of the key aspects of being able to do these reintroductions is actually having animals to do reintroductions with. And so I will give a couple of examples of some zoo programs that we have, but we often have to go out into the wild and find these species. We have to go and understand what's happening with their populations, and we have to go to where they are. So for instance here, there is actually a rock wallaby in that red circle. I promise you it's there. We would have to go out into that environment and undertake surveys to find out what's happening with the population there, and whether we're able to use some of those animals to be able to undertake reintroductions or translocations. What we often find is that there aren't necessarily enough animals to be able to do a full translocation, and one of the roles of the zoo is to be able to deliver captive breeding programs. And a couple of examples here. One is a greater stick nest rat, and so these guys are really badly impacted. You can see from the light orange on Australia, that was actually their historic distribution. So they used to live in a really large area, and particularly in South Australia. The little red dot is basically where they're left. So they're only really left on a couple of islands off the coast of South Australia. And we were part of a breeding program to go and collect these greater stick nest rats and bring them to the zoos to breed them up. And we talked about homes. Well, this is their wild home. They're called greater stick nest rats for a reason. The top picture is a picture of their habitat out in the wild. So they spend a lot of their time going out and finding sticks and browse and leaves, and they weave it all together, and they make these really strong nests. In the zoo environment, we have to be able to provide them with those homes as well, because they use those nests to raise their young. And so that's not a pile of sticks that our keepers have decided to dump in one of their enclosures. That is actually a nest that the stick nest rats have made themselves, and it's pretty strong, and you can basically lift the whole thing up in one piece. It's pretty incredible what they're able to do. Being able to provide them with the right homes and the right environment, we've been able to have a really successful breeding program. And so this is one of our very proud mama stick nest rats, and if you look closely you can actually see that she's got two little pups attached to her. So those pups are now part of a reintroduction program. They've actually been released into New South Wales, and through that captive breeding we've been able to bring that species back from extinction in New South Wales. We've also just commenced a really new program, so we're working with red-tailed phascogales, and a bit like the greater stick nest rats, there aren't really enough in the wild for us to be able to successfully create a whole new population. So working with our partner Australian Wildlife Conservancy, they headed over to Western Australia where there is a stable wild population left over there. They actually headed over there for 2 years before we were able to get animals within the zoo. So the climate, the conditions played a really important role in determining how healthy that population was and how successful their wild breeding had actually been. And it wasn't until this year, where they had a really good year, good rains and a good healthy year, that we were able to bring some animals from Western Australia into Adelaide Zoo. Those animals have been able to breed, and this is a picture of the pouch of one of the girls here. So there's about 8 little joeys in her pouch. The females have been really successful. One of the things that's really contributed to that success is we looked at the conditions in Western Australia and we timed the movement of those animals to when South Australia and Western Australia were really closely aligned. So one of the things that we think actually impacts these species is photoperiod, which is basically the length of the day, what time the sun rises and what time the sun sets. And we think that there are some environmental cues associated with that. So we timed when we moved the animals so that it didn't disrupt their natural behaviours too much, and we were able to get them here. We've had a really cracker season. I think it's probably one of the best breeding programs that we've had here. We're looking at, by the end of this year, we will probably see over 100 red-tailed phascogales back into New South Wales for the first time. So that is a really great example of how you can go from a wild population, and we can really amplify those animals with a captive breeding program and get them back out. And we'll be able to work with this species and hopefully reintroduce them not just back into New South Wales but into a few other locations in Australia. It also takes the pressure off of that wild population too. So they're not under so much stress. They're not having to provide animals for these other reintroduction locations. We can help support that. But there's a lot of information that goes into deciding whether or not we can take animals from the wild, but also how we deliver these conservation programs. We use tools. There's a program called Vortex, and that is actually an extinction simulator. So we can put information in there such as what sort of mate selection species have, how long their reproductive cycles are, how long do they live, how far do they move, and you can use that information to predict how long it's going to take for a species to go extinct. Now, our ideal scenario obviously is that when we've got animals and we're doing reintroductions, or even with our zoo population, that we don't want those animals to go extinct. So we can look at what sort of numbers we need and what sort of changes we need to do within those populations to ensure that we don't reach that point. So it's actually a really important survival tool for us. We can also look at information such as age structure. Age structure is really important to make sure that you've got a balance between young animals coming through as well as reproductive animals. If you end up with a whole cohort of older animals that aren't necessarily reproductive anymore, that's the end of your population. So age structure is actually really important. And you can look at your own families as to what your age structure might be. No difference to how many grandparents you have, how many cousins you have, how many nieces and nephews, and you could actually build a bit of an age structure for your own family. We use it as a really important tool here to understand whether we've got enough animals of the right age within the population to be able to keep that population healthy. We also look at how many animals we have in the population, and this is a little graph down here over time. That's actually years. I can't remember what species that was, but it's a graph of how many animals we have within a captive collection, and it divides it into males and females, as well as the total, the black line up the top. And you can see that at a point about 10 years ago, we had a really massive boom. I think this is brush-tailed bettongs. We had a really massive boom in the captive population, and we've been able to maintain that boom as well. So you can look at what's happening with your numbers. And I say in the captive population, it's not just us doing it. A lot of this information takes the animals that are being held across other institutions as well. So this graph itself would actually be a picture of the global population of bettongs. So that's bettongs here, that's bettongs in Victoria, in New South Wales. I think there's even bettongs in Hong Kong and Germany. There's bettongs in all sorts of places, but we can look at what that demographic is within that population, and we can make some decisions around it, because if you don't have very many animals in the captive population, you might not necessarily be ready to be able to do reintroductions. You might not be able to afford to lose those animals to a wild population, and so we need to use that information to make some of those important decisions. So once you've got animals, you've got a safe environment, what else do you need? We need to be able to move these animals around. And understanding about the animals' needs and their behaviours is a really important science for us to be able to ensure that we can transport these animals safely and ensure that we're providing the right welfare conditions. The same as you might take your dogs to the vet, just throw them in the car. You might not do the same with your cat. You want to make sure that your cat gets to the vet safely, and you'll put them in a cat carrier. So we do things like transport animals in transport boxes or pet carriers to make sure that they're nice and protected, that they're not going to get injured. A lot of our macropods, our kangaroos, and for instance our bettongs, we transport and hold in sacks basically. The sack then creates a bit like an artificial pouch, and they curl up and they feel like they're back in the pouch again, and they really quieten down. If you were to put that on the ground, they'd probably wrestle around a bit, get quite agitated. And so it looks a bit strange, but there's actually bettongs all hung up nicely, all sleeping in a row. But that's come from us learning about the science of their behaviour and being able to apply that to our translocation programs. One of our really interesting programs has been working with the Mallee emu wren. And these guys are a really small species. They have a really high energetic requirement. And so we had to look at their movement what sort of food resources they might need, what sort of shelter they might need, to be able to provide them with a transport box that was going to help them survive their journey. One of the things that we learned was that it was actually better for us. You might think that the fastest way to get somewhere is always going to be the best way. But for emu wrens, it was actually better for us to be able to move them over 2 trips. And we're able to hold them overnight, provide them with a huge amount of insects. They can eat an enormous number of crickets and mealworms so that they have that energy store ready for the next day when they got released into the wild. And so that's actually a picture of emu wrens sitting in the Lameroo district office, waiting to be moved, where they've all just been fed. What that meant for us when it came to doing the translocation is that we actually had to provide all of those things for the animals. And so this bottom picture here is a cricket setup. So we had to take crickets out into the wild. Sounds fairly simple, take some crickets out, but crickets don't like the cold very much, and we were working in temperatures that got down to 0. So we actually had to pack solar panels, batteries. We probably took more equipment for being able to keep crickets alive to be able to provide the food resources than we did for actually moving and catching those emu wrens. A lot of that information we actually learned in the zoo. We learned from having a similar species how much food they required when they were under our care and what we needed for their husbandry here, and we then applied it to a wild situation, and we were able to move animals safely and give them the best chance of survival. The fun part, the part that everyone sees on the news, is always the animals being released. That's a little emu wren flying very rapidly out of a box there. Even releases themselves take some consideration. You need to think about what time of day is going to be most suitable for those animals to be able to survive, how long it's going to take for them to find shelter, and what sort of food is going to be available at those times of day. You don't want it to be too hot for them because it might impact their dehydration, and so we take a lot of those things into consideration when we undertake releases themselves. So even though it is that sort of snapshot moment, there's a lot of science and thinking behind it. And some of the more critical things that come out of the reintroductions, and probably the long haul part of most of our efforts, is the monitoring. What do we do afterwards? And so you'll sometimes see things like radio collars attached to animals. So this wallaby down here, that white thing underneath its neck, is a radio collar. It's got a VHF transmitter in it, and you can use an antenna to track what's happening with those animals. Go and find the signal that's associated with that animal and look at whether it's survived, how far it's moved, what's it been doing since it's been released. And this is an example down here. These are a couple of waroo rangers. This is a black flanked rock wallaby, also known as a waroo locally. And these waroo rangers are out and they're trying to radio track the animals after they've been released. This is actually an example of a radio collar that was once on a waroo. So they're quite, quite small, and they provide us with a really great deal of information about those animals, where they're moving and what their survival looks like. As technology has advanced, we now have access to GPS, so global positioning satellite technology. We have satellites up in the sky, and we can get some radio collars that automatically transmit to those GPSs. So rather than having to have someone like these Adelaide rangers go out into the field and track those animals by foot, the picture up the back is actually a bunch of animals that have collars on, and you can see where those animals have moved within the environment. For instance, there's the dark blue line. That animal has probably moved over 10 kilometres, up, back, all around the place. The red animal on the right hasn't moved very far. And so we not only get survival information from these animals, we also learn about their home range too. How much of the environment do they need to be able to survive? How far are they moving? How far do we have to go to look if we want to find them? And we have had instances where we've had radio collars attached to animals, where we've had to send a plane up with an aerial on it to go and find where that animal has moved, because they've moved much further than we can either track by foot or by car, and the landscape's so big that we don't know what direction we'd even need to start in. So we can attach the technologies to planes and send them up to go and find these animals. The monitoring part of it really is long term. And so we're part, for instance, with the Warrior program. We've been involved in that program since 2006. We still have staff go up every year and undertake parts of their trapping efforts. We're still part of the reintroduction program, moving animals around the landscape and reintroducing them to hills where they've recently gone extinct. It's a huge effort to keep these programs going over long term, and it takes a lot of resources to be able to keep them out there, to be able to have people on ground monitoring and gathering that information. Because if we put some animals out now, we want to know that they're still going to be there in 10 years' time. Otherwise, why did we bother? That's the important part. As EB mentioned, one of the programs that we've been working really closely with is with the Kangaroo Island Dunnart. And these guys are really badly impacted by the fires on Kangaroo Island. At the time, we thought that there were less than 500 left in the wild. We're still not 100% sure how many there are, but they have been detected on remote cameras, a bit like we saw with cats and foxes. That picture up the top is actually a picture of a Kangaroo Island Dunnart. It's only about this big though. And we use those cameras to look at the occurrence data to find out where those animals are still living, where they might have moved to. Cameras aren't great for getting information on how many animals they are. You can imagine every time a Dunnart walks in front of a photo, depending on whether it's the same animal or a different animal, the pictures look pretty much the same. They don't have striking features that differentiate different individuals from each other. And so we still want to get a really good handle on what's happening with that population. And so we've been working on doing some trapping, and there's a picture of the bottom of a pitfall trap. Unfortunately, it doesn't have a Dunnart in it because we haven't caught one yet. But we are doing a lot of work to try and find the best ways to go out and get our hands on some of these animals to try and learn about them. We've also been doing some work with radio collars. And this is actually a picture of a fat-tailed Dunnart that we have here at the zoo, and we're using them as our example to try and get a radio collar that's going to fit a Kangaroo Island Dunnart. Now, I also have a radio collar that fits Dunnarts, and it looks a little bit different to what the radio collar looked like for the wallaby. They're obviously much smaller. We have really specific weight ranges that we want to make sure they don't impact on the animals. And so the little Dunnart radio collars weigh less than a gram. Pretty crazy that we can get technology to that size. They don't have the same sort of battery life, so we wouldn't get as much information as you might from a rock wallaby's radio collar, but we can still get some really critical information. And so our next stages of our project are going to be going out and getting some of these radio collars on some Dunnarts on Kangaroo Island and learn about how they're using their habitat since the fires. The other program that EB mentioned was our Marnabungara program, so the work that we're doing down on York Peninsula. And I mentioned before that it takes a huge cohort of people. This is a really great example. This is a great consortium of organisations that have been coming together for the last 10 years to look at what we can be doing on York Peninsula. The program is really about rewilding. It's about getting some of those species back that can impact the environment and have great outcomes for the ecosystem, but not just the native vegetation, but also working with agriculture too. So species like making sure there's enough owls in the system that might be able to impact mice and prevent mice plagues, rather than having to do other invasive methods. One of the first species that we've been working with is a brush-tailed bettong, and I'll show you a short video shortly. The brush-tailed bettong are known as an ecosystem engineer. And so they have quite sharp claws, and they'll dig in the ground and they'll create little divots in the environment. And these little pits, they're able to collect seed, they're able to collect leaves and leaf litter, and they almost create their own little microenvironment. What's been found is that the microenvironment created by these bettongs actually produces the conditions that are required for a number of our plant species to germinate. So if we don't have these bettongs in the system, we don't have these microenvironments being created, those plant species aren't coming back and aren't growing. And so that's why we talk about rewilding as being really important. It's not just about those animals, it's about that bigger picture impact on the system. Now I'm going to stop talking at you for a minute and play a video. the video did end abruptly. That translocation only happened last week, hence why the video ended up quite so abruptly, is that there's obviously a lot more to that story. And so for me, you know, that's a really good snapshot of, you know, that 5 minutes really demonstrates how much goes into these programs, and hopefully you've been able to see some of the background science to actually make that really exciting moment at the end when those animals get released back into the wild. That it takes a lot of planning. It takes, you can see just the number of people with that event itself. We were very fortunate that we also had the local community, and like Evie mentioned, we work very closely with the Aboriginal community. The Narungga community came out and performed a smoking ceremony for us as well and blessed the animals before they were released. So there's a lot of planning that goes into these sorts of events and into these sorts of releases. But there's also a lot of science behind it as well. And so yes, there's 5 minutes of very exciting things happening, but there's also 10 years of work behind it, and very intense. That was 48 hours and, you know, no sleep to get all of those animals processed within one night. And, you know, you really have to be prepared and know what information you want to be gathering from those animals. You want to have done your research to understand what sort of radio collars you want to be using, and how many animals you want to be taking, what's the sort of habitat they're going into, what sort of numbers of females and males do you want to be releasing, what do they occur, what sort of rates do they occur at, where they've come from, what sort of numbers do we want to put in so that we can get the reproduction that we want for those animals to create a sustaining population. And so I will leave you on that, and this is a little photo of one of the bettongs from this week who's popped up on one of the predator cameras with his collar on.
Well, I think you'll agree that Liberty and her team just do fabulous work, and this is a little snapshot of that. So first of all, any questions from anyone in the audience and also online? So maybe first of all, yes, you might have a question.
I was wondering how long the collars stay on. Do they come off naturally, or do you have to take them?
So they're designed really species specifically. Something like the tiny little Dunart collar, we actually use a fine surgical tube, and within that we run a piece of cotton thread, and it's actually the cotton thread that is holding the collar on. So we know over time there's a very low chance that we will recatch those animals, but we know over time the cotton will start to degrade. If they get caught on anything and they struggle, they'll be able to break that collar off themselves, so it won't create issues for them. Bigger collars like rock wallaby collars, this one for instance is cut, so this has come off of an animal because we know we're working in an area where we trap in that area regularly, so we know there's a high chance of us catching that animal back up again. It means that the collar can be more robust and it can have a much longer battery life. So something like the little Dunart collar, depending on how often you're taking readings from it and how often it's sending a signal out, you know, it might last between 2 weeks to 2 months. Something like a rock wallaby collar can last up to a year. So you can get a lot of information from those collars. And even larger collars, you can do things like sew a little breakaway section, a little bit of different fabric in there so that it does degrade and come off over time.
How long will it be before you can go back to Wedge Island? How long will it take that bettong population to sort of recover from 40 animals going out so that you can harvest them again?
Yeah, really great question. So we're looking at doing harvests over the next 2 years. We're actually looking at getting some animals from Western Australia. And so we were impacted by COVID. We were meant to be getting 20 Wedge Island animals this year with 20 Western Australian animals. We couldn't get across the border, so we've taken 40 animals. The Wedge Island population is estimated at about 1,500 animals. So it's not likely that taking those animals would have had a huge impact on that population. But we do take that into consideration. And when I talked about monitoring, it's not just necessarily monitoring the animals that you've moved, and when you've released, you go back to those source populations and make sure that you haven't impacted them.
Courtney, maybe a question from online?
Yes, so we did have a question from Leanne, which I believe was in reference to the brush-tailed bettongs. She just asked, why are the animals being released in New South Wales and not here in SA? But I believe they are in both.
Might be the Fascigales,
Oh,
maybe. Yeah. So at the moment, New South Wales have the Sturt National Park, and that's where those Fascigales are getting released into. So they've done a lot of work to set up fences over there to undertake their predator controls and have that park ready to put some of these species back in there. There are locations in South Australia where we're working with partners to get those areas ready. So for instance, over the coming years we might see Fascigales down on Yorke Peninsula as well, like where the Bettongs are, as well as some locations in the Flinders Ranges. So they're in planning.
I think Liberty highlighted a really important point there. It takes a village to save a species, and it's really important to mitigate or remove the impacts on that species in their natural range before you reintroduce the species into that natural range. Otherwise, it's really a fool's errand, and there's a lot of work that goes into that before you actually start to release species. So another question from, yes please.
Was there a reason why you released the Bettongs during the day rather than at night? Because I believe they are a nocturnal species, aren't they?
So it's probably more so a bit of camera trickery. So they were actually released right on dusk. So you might have seen, probably a couple of the really nice images were right on that dusk point where they could get enough lighting to get some good pictures. But then, the rest of them were ones that got really quite dark, and that is, you're right, a very important consideration. If you release an animal that's naturally nocturnal, you release it during the day, it already is potentially a bit stressed from being moved around, and then you're putting it into a foreign environment where it's got to find shelter, and they tend to stress out. They wouldn't naturally be awake during the day, and so we try and take that into consideration and provide that natural behaviour for them. So most of our native species we would release at night time.
Courtney, another one from online?
Yeah, so another question here from Jill, who asked, how do you choose the animal?
The individual animal or the species?
The species.
The species.
Yeah.
That is like the $1 million question. We have, I guess, some pretty important criteria. So making sure that, those we're working on that habitat, that the species that we're working on have somewhere where they are able to go. And programs are going to really build for those species too. For instance, the Fascigale is a great example where, yes, we'll be able to continue breeding here at the zoo, but we'll probably be able to also use the population that we've just reintroduced as a source for future translocations as well. It also is largely dependent on what our federal and our state government priorities are as well. So you might see things lists like the top 20 mammals and the threatened species strategy that our federal government outlines, and so they provide us with funding. Funding is a huge part of it too. And we also look at how at risk those species are. So what is the risk of those genuinely going extinct? What role can captive breeding play? Captive breeding isn't necessarily going to be a solution for all species. And we do a lot of feasibility studies to understand whether captive breeding is going to be a successful tool or not. So there's a lot of things we take into consideration before we start going down the pathway of reintroductions.
The population that you just released 2 weeks ago, when will you first go back and monitor them? And also the issue where, that one's on the camera trap, and camera traps can pick up, give a false representation of the population because it could be the same animal going back and forth.
Yep.
Do you think you'll move into drone technology where they're able to capture much larger images with, infrared technology, and you can actually, in the photograph, count the number of individuals because it's, taken in a moment of time and they're not moving?
Yeah, absolutely. So some of that aerial technology you can use for a lot of the larger species. And drones are improving all the time with the amount of power they have, so you can even attach some of the tracking antennas and things like that to drones to be able to get that information. We were working with the University of Adelaide for the Bettong releases, And so there's actually a couple of really large radio towers. So what got lost off the end of that video was actually a picture of a radio tower that has been placed. We have 3 of them out in the park, and they're actually picking up the signal for those antennas. And there's a PhD student out there who's looking at the survival, so she goes and she checks what information is coming from those towers, and she's been out there basically every day since we released those animals. Next week we're going to head back over to the peninsula to catch up a few of the animals, just make sure that their collars are fitting really well, have a look at their weights and make sure that they're in good condition. So it's a constant monitoring of what's going on, and certainly before we do any more releases into that area as well, we'll be doing some population surveys.
One from online? Okay, any other questions from the room? Or right back, yes.
You mentioned earlier using some camera tracks to work out predator density in an area that you might consider reintroduction, and then also stuff like aerial baiting to try and bring that predator count down. In an area where you've done a reintroduction, what kind of strategies are in place to prevent encroachment by predators again into those areas?
Yeah, so we use a number of different tools. There's a predator control tool called a grooming trap or a felixer. That's a fairly new technology. It has a number of laser sensors that basically detect the shape and the size of an animal when it crosses those beams. And if it cuts off the right number of lasers in the right order, it presumes that that's a cat. It has gone through a lot of testing. We did some testing on non-lethal modes with a lot of our zoo animals to make sure that it wasn't being set off by a native species. But that trap itself then basically ejects a poison onto that cat, and the cat grooms it off. They use their natural behaviour to groom that poison off. So that's one of the tools. We do have access if we were to find out something was going on, or we knew that there was a particularly nasty cat or fox in the area that was jeopardising the survival of these guys. We have access to professional shooters as well, so they're able to go out and really do some targeted efforts. We're also able to do things like trapping, so we'll be able to get a picture of what's happening with those animals as well. So there's a whole range of tools, and aerial baiting. A lot of research has been done on the success of aerial baiting and the nature of the baits most of our native species are immune to. So it's using a naturally occurring plant species that occurs in Western Australia, and so our animals are able to basically tolerate the toxicity that these baits have for cats and foxes.
It all sounds a little alarming, but all these techniques are passed through ethics approvals. They're humane, and clearly the intention is obviously to augment populations of wild species, and the introduced species unfortunately are having such an impact that these measures are necessary. Right, any final questions? Oh, one more.
Sorry. I know that ZFSA has done incredible work helping with species like the Mongolian wild horse. What are some other global species that ZFSA contribute to?
Yeah, so we have, we have a whole range of global management species. So even things like orangutans here, particularly rhinos. A lot of that work, we manage those species within the zoo institutions at an international level. There's obviously a lot of work going on in planning for rhinos coming to Monado Safari Park as well. We also do a lot of support with international partners where we provide funding for them to be doing on-ground work too.
Yeah, I might just add to that, because it's a really, really good question. I guess one of our views we hold, Adelaide does amazing work with Australian native animals, and I hope you've been seriously impressed with the work that she does. It's why she was in one of the the top 40 under 40-year-olds in South Australia. Woohoo! But we also hold a number of non-Australian animals, and I guess our view is if we're having under our care an animal that's not native to Australia, we should be doing something to help it in the wild. And so we do partner with a whole range of international partners. We can't necessarily do a release to the wild that easily. We did with the Przewalski horse, with the Mongolian wild horse, but it's quite a challenging thing to do. So our view is more that we can work with partners. And so if you look at, we hold, Sumatran tigers, orangutans, chimpanzees. For every one of those species that's in danger in the wild, we've got a conservation partner. And so there's always ways that people can help. We hold ambassador animals. We can hopefully breed Sumatran tigers. COVID gets in the way of imports and rhinos is really challenging. But we can really raise the profile and hopefully help those animals in the wild.
All right. Well,
You're on.
So I guess first of all, I'd like to thank you all very much for coming out on a cool night. I think you'll agree that you've really seen an impressive presentation this evening. We're very fortunate to have the talented Liberty Olds on our team, and obviously being ably led by Elaine. I just wanted to remind you as you leave this evening that we are a conservation charity, and what you've seen tonight is really the sort of sharp end of our efforts as Zoos SA. And as EB just mentioned, not only do we do all this work with native species, but we actually partner with multiple organisations across the whole planet that do conservation in the wild. And even a number of our employees, a number of our team actually do other conservation work themselves and various side projects and supported by the zoo and even sometimes obviously in their free time. So just as you leave this evening, no obligation, but as you leave, if you think you would like to contribute to some of this work, we actually have a tap and go donation facility at the back of the room. And just want to thank you all very much again for coming tonight. And I hope you visit the zoo and continue to support us, and thank you very much. Thank you very much.